Good afternoon, children. Today we are going to start with amines and its previous year questions. We don't have much questions on this, so a very few ones but important ones. So let us begin with the first question. So here's the first question on your screen, and as you are not able to see the question, I'll become invisible for a moment. Just read the question and then we'll do it together. Okay, children, I hope you all would have read the question. So let us see what the question is being asked. Which one of the following nitro compounds doesn't react with nitrous acid? It's asking which one does not react with nitrous acid. Yes, so how do you identify the one which doesn't react with nitrous acid? Is the one which does not have alpha hydrogen, right? So you all can spot here that here nitro compound is present in all these cases, and this one is your alpha carbon. Yes, children? Okay, so as you can see, in the first case you are having 2 alpha hydrogen. In this case also you have 2 alpha hydrogen. In this case you have 1 alpha hydrogen. But in this case you see that there are no alpha hydrogen present here, right? So there are no alpha hydrogen present. So as there are no alpha hydrogen present in this compound, so can I say that option C is going to be the correct answer? So the takeaway point here is that when you try to react with HNO2, you need 1 alpha hydrogen. Yes, so that is the catch point here. Yes, so this is going to be your correct answer. I hope everyone is clear with this question. So let us move on to the next question. So the next question on your screen, and it's talking about Hinsberg reagent. Try everyone. Okay, children. So let us discuss this question here. What is being asked to us? Number of compounds which give reaction with Hinsberg reagent. So how many compounds out of all this given compound is going to react with Hinsberg reagent? So what is Hinsberg reagent, children? It's benzene sulfonyl chloride, right? Okay. So this is your benzene and we have sulfur, 2 oxygen and this. Yes. So this is going to be your Hinsberg reagent. Yes, children? Okay. So talking about the number of compounds, so who all react? This is a test. As you know, this is a test for amines, right? This is a test for amines. So the amines are going to react. Who is going to react? Amines will react. And in case of amines also, there should be hydrogen. Yes, there should be hydrogen. Okay, hydrogen must be present. That is, it is trying to tell us that only 1 degree and 2 degree amines are going to react. 3 degree amines do not react with Hinsberg reagent. 3 degree amines do not react with Hinsberg reagent. So which of the following are not going to react here, children? Okay, so let us see here. This one is disonium salt. It is not going to react. Okay, this is again not going to react. Why, children? Because these two groups are present here. Yes, then looking at this one, this is also not going to react because this is tertiary. This is tertiary. Again, this is tertiary, so this is not going to react. Yes, again this is pyridine, this is not going to react. Yes, then again this one is your amide. No, this will react, right? Let us see. So what is going to be your answer, children? this is going to react. So how many compounds are there which is going to react, children? Let us see. So what is the answer? Your answer is 5. So 5 compounds are going to react, right? Yes. So this one is going to react 1. This is 1, 2, 3, 4 and 5. Yeah. So these 5 compounds, they are going to react, children. Yes. The rest of the following, they are not going to react. As you can see here, hydrogen is there which can be used. Yes. Again here this is 2 degrees, so this can be used. Yes. Again this can be utilized. Yes. This is 2 degree. Okay. And this is 1 degree. This can react. So these 5 compounds, they are only going to react. The rest of the following, they are not going to react. And you should remember, children, Hinsberg is a important reagent for us. Talking about Hinsberg reagent, we know that this is the compound when it reacts with primary amines. Yes, it gives us a compound. It gives us a compound which is soluble in alkali. Which is soluble in alkali. This is for 1 degree. Yes, in case of 2 degree, it is going to react, but it is not soluble in alkali. Yes, children. Then we have the 3 degree one which does not react. No reaction. Yes, children. Okay. I hope this much is clear to you from here. Let us move on to the next question and see what it has for us. Yes. So next question is on your screen, and try, everyone. Okay, children. So let us see what is being asked in this question here. Okay. So the question that is being asked here is the compound formed by the reaction of ethanol with semi-carbazide contains how many number of nitrogen atoms? Okay. So you might make a mistake here without solving this. Yeah. You might find out the answer as 2, but the answer is not 2, right? Yes. Okay. So let's see what is the answer. Ethanol. So it's C double bond O, hydrogen and CH3, right, children? Yes. Then is semi-carbazide. So what is the formula of semi-carbazide, children? The formula of semi-carbazide is, you know, that it's C double bond O, NH2, H2N, NH. Yeah, this is the compound. Yes, this is your semi-carbazide. So this is your ethanol, and this is your semi-carbazide. Yes. Okay. So if this is semi-carbazide, you have to remove water from here. What are you going to remove? You have to remove water from here. So minus H2O. So as soon as water is removed, so what is going to be your product? Yes, children. So this is going to be your product. When this is your product, now we have to find out that how many nitrogen are there. This is 1, 2, 3. So as you can see, children, there are 3 nitrogen atoms. So the answer is going to be 3. Yes, the answer is going to be 3. Yes, so 3 should have been your input. I hope this is clear to everyone. Yes. Okay. So next question on your screen, and try. Okay, children. So let us see what is being asked here. The number of isomeric aromatic amines with the molecular formula C8H11N, which can be synthesized by Gabriel thalamide synthesis. Okay, so it's asking us which can be synthesized by Gabriel thalamide synthesis. So we know that this is C8H8N, right? So this will be CH2, CH2, NH2. This is a very basic one, right? So like you see, there are 6 carbon here, 7, 8, yeah, and there is one N, and we have 11. Already there is how many? 1, 2, 3, 6 hydrogen, and here we have 5 hydrogen. So this is having the formula C8H11N, right? So this is one. Okay. What can be the other ones, children? Other ones can be that we have to anyhow keep NHCH2 NH2 here. Why, children? Because preparing aromatic amines is difficult using the Gabriel thalamide synthesis because the anion form is not stable, right? So we already know that. So the second one, this is going to be CH2 NH2, and you can keep CH3 here at the ortho position. Similarly, what you can do is you can keep it at the this position, meta position, right? Yes, one more if we want to see at the para position. One more if you want to see. Can I put and CH3 here, right? Yes or no, children? So these are all the possibilities. Is there any other possibility that can be done here? No, we cannot just write NH2 and CH3 CH3, right? So that won't be correct. So that's it, children. Yes. Okay. So next question on your screen. Try, everyone. So what is the question here, children? The question that is being asked here is, how many of the transformations given below would result in aromatic amines? So the question is that how many aromatic amines can be formed, or which of the following is going to give you aromatic amines, right? Okay, so let us see. This is the first reaction. Yes, as you all know, this is Hofmann bromamide reaction. And in Hofmann bromamide reaction, one of the carbon is going to be reduced. So this carbon is going to be reduced here. So what is going to be the product here, children? Okay, now this reaction, as you can see, children, okay, so this is resembling your Gabriel thalamide synthesis reaction. Gabriel thalamide synthesis, and we know that we cannot take aryl halides here, right? We cannot take aryl halides here because the anion form will not be stable. Yes, this is what we know. So this is not going to give us aromatic amine. Yes, and this is a normal reduction of nitro compounds, and when nitro compounds are reduced, you get amines. You get amine. So here you are going to get again NH2. Yes or no, children? Here also you are going to get NH2. Now this one, if you see, it's a direct reaction. You're going to get here NH2 and CH3COOH. So you're going to get this. So in how many products you're getting aromatic amine? So this is 1, this is 2, this is 3. So the answer is going to be 3. So how many transformations would result in aromatic amines? So in case of 3 transformations, you are going to get your aromatic amines. Yes, children? Okay. Okay, so the next question is on your screen. Again, a similar type question. Okay, so try this, everyone. Take a minute and try. Okay, children. So let's see what is being asked here. The question that is being asked here is the total number of reagents from those given below that can convert nitrobenzene into aniline. So we are talking about conversion of nitrobenzene into aniline. So talking about this, children, we know that this process will be a reduction, right? And it will occur by reducing agents. Let's see which of the following are going to satisfy our condition. SnHCl, we know it's a good reducing agent. FeHCl is the best reducing agent, the scrap iron, right? Okay, so by using scrap iron we get the best one. Yes, because here HCl can be reformed, okay, renewed. Then ZnHCl is also reducing agent. So again H2 with palladium, this is a good reducing agent. H2 and nickel, so these are reducing agent. But SnNH4OH, this is not a reducing agent. This, children, is not a reducing agent. So if we count the number, this is 1 2 3 4 5. So 5 is going to be your answer. 5 is going to be your answer. We are going to have 5 number of reagents which can convert nitrobenzene into aniline, because these are reducing agents. Yes, okay. So next question on your screen, and I'll become invisible. Okay, children, so let's talk about this question. What is being asked in this question? In gaseous triethylamine, we're talking about gaseous triethylamine here. Okay, so triethylamine is nothing but your CH2CH3. Yes, children. Yes, so this is your gaseous triethylamine. Yes, so talking about this, here it is asked the CNC angle. This angle that it is being asked to us, right? So as we can see, children, here that nitrogen is having 3 bond pairs. It's having 1 lone pair here, right? Yes, so it's having 3 bond pairs and 1 lone pair. 3 bond pairs and 1 lone pair. So this is going to be sp3 hybridized. Yes, with 1 lone pair. So your bond angle is definitely going to be 108 degree. Why 108 degree, children? Because there is going to be repulsion. There is going to be repulsion, so the bond angle decreases. So the bond angle decreases. So what is going to be the answer, children? Your answer here is going to be 108. The answer is going to be here 108 degrees. Yes. Okay. So again, the next question on the screen: total number of amines which can be synthesized by Gabriel synthesis. Okay, again a conceptual question. Try, everyone. Okay children, so let us discuss what is being asked to us in this question. The total number of amines which among the following can be synthesized by Gabriel thalamide synthesis. Okay, so talking about Gabriel thalamide synthesis, we know that primary amines can be synthesized. Right children? Primary amines can be synthesized. Yes, okay, so primary amines can be synthesized, but we know that we cannot use ArCl as a substituent. This cannot be used, right? Okay, so ArCl cannot be used again as a reactant here, because we know that anion won't be stable. Yes, so here aromatic halides cannot be used. So if we see in this reaction children, this does not involve any aromatic compound, so this is all right. So this is going to be produced. Again, this is aliphatic, this is going to be produced. This has CH2 then NH2, so this is also going to be produced, but this children you cannot produce, okay, because this would have been made the use of aromatic halide, which is not possible. Yes, so these three are going to be your correct answer, and your answer is going to be 3. Your answer is going to be 3. Okay, so as you all can see here children, that out of all the name reactions that is given to you, the most important ones are your Hoffman bromamide reaction, and another is your Gabriel thalamide synthesis. So you have to look through all the aspects of these reactions. Okay, so the exceptions of these reactions, what are the reagents, what are the reactant used in this reaction, and then only you can proceed further, because every time you are going to get questions from these parts. Yes, okay. So next question on your screen children, and try. Okay, so let us see children what is being asked in this question. A compound is given to us here. Let us draw that compound. Okay, then we are given ethyl magnesium bromide and H3O plus. We know that this reagent is going to form your ketone. This is a preparation of ketone. Yes or no children? Yes. So this is going to give us yes children, so this is going to give you ketone. Yes, so when it gives you ketone, the next step is reaction with CH3MgBr. What children? CH3MgBr, and we know that when ketones react with CH3MgBr, they get reduced to alcohols. They get reduced to alcohols. Yes or no children? Okay, so this compound is going to change into alcohol. Yes, and the CH3 is going to be added here. CH3 is going to be added here. Now here it is being asked the number of chiral centers which is present in B. So if this is A and this is B, so if talking about this, so what are the number of chiral centers? Let us check. Where can it be possible? It is possible here. Yes, we can see that 1, 2, 3 and the fourth group is hydrogen. So this is one chiral center. Yes, children. Okay. Now, if we look at this center, is this a chiral center? No, this is not again a chiral center. Now, let us look at the other part. Okay. So, can I say that this one here, yes, this one here, can we identify this as a chiral center? Yes, this again is a chiral center. Yes. Okay. Then, again, looking at this part, children, can I say that this is a chiral center? Yes, this again is a chiral center. Okay, so now there is one more chiral center here. There is one more chiral center here. Yes, there is one more chiral center here, and it is 4 chiral centers. And tell me which one of the following is going to be your chiral center. So there are 4 chiral centers here. I have identified 3 for you. Find the other one, and also tell me whether this one here is a chiral center. Yes, tell me whether this one here is a chiral center. Okay, so how many chiral centers are going to be there? There are going to be 4 chiral centers. There are going to be 4 chiral centers. Yes, children. Okay, so as you can see, children, here there is one bond here. Yes, then there is entire this bond here, and there is entire this bond here. So now check and tell me if this center is a chiral center here, and if not, then which one is your 4th chiral center? So there are 4 chiral centers here. Yes, okay. And as we know that what is chiral center, children? Chiral center is that which has asymmetry, right? That means the 4 groups attached are different. Yes, the 4 group attached are different. So we have 4 chiral centers. Okay. So that's it, children. Okay. So if you're talking about more concept in things of amines, what are the important parts that you should look and go? Talking about the reactions, children. So most important is your as we thought that is a Gabriel thalamide, Hoffman bromamide. Okay, then you are also going to look at the pKa and Ka concepts. So sorry, pKb and Kb concepts. So we are talking about basicity here. Okay, and also you are going to look at the reagents, okay, which are used for testing your HNO2, okay, carbalamine reaction, and you're going to look at Hinsberg reagent, very important. Yes, this is what you are going to look at. And what are the other things that you are going to look at? You're going to see your diazonium salt. Look at the basic just reagents, okay, and their products. So that would suffice for your amines. So you don't get much very difficult questions in this, okay. So that will be enough for that, okay. So with this, we end this session, children. I'll see you in the next class. Take care and bye-bye.